Good morning, everybody. Hope everybody's had a fantastic day. I hope the review that you guys have done the last couple of days has been helpful and giving you plenty of time to work on that in class. Hopefully has aided in the process of making sure you guys knew what you were doing. But today we're going to be looking at 9.4. So go ahead and take your ebooks, open up to page number, it looks like it's on page 398, and make sure you're following along with me as we're going through this. Today, we're going to do 9.4, solving rational equations. So the last couple of lessons you guys have added, subtracted, multiplied, and divided rational equations. And today we're actually going to use them to solve. The lesson's not too bad at all. It's really just solving simple equations. But sometimes your unknown is going to be in the denominator. And there's just a process involved in order to making sure we can get rid of that. And then there is some application that we're going to be looking at, some word problems. So I think you guys, we'll go over a couple of them, make sure you guys understand how to set them up. Okay, if you guys can recall, these are some equations that we're used to solving. We know they're equations because they have an equal sign. That's the dead giveaway. And in the first example, you got the variable x. The second one you have y, and the third one you have x as well. The secret to success on these types of problems, particularly the second two, because I feel confident that everybody in here knows how to do the first one. You know, just subtract 7 from both sides and then divide by 3. You solve for x, no big deal. Now the other two, though, you have fractions, and usually we always want to get rid of fractions. So that's exactly what we're going to end up doing. So in the first one, what I would recommend to do in that first example is I would go ahead and multiply every single fraction by 3, or every single term by 3, I should say. The second one, you want to look at your denominators and multiply everything by the least common denominator. Least common denominator or least common multiple, a way you can think about it, between 5 and 2 is 10. So I take 10 and multiply every single term by 10, and that would get rid of my fractions. And by doing that, you end up getting a simple equation that you guys can solve for. So it's really not too bad. I think you guys can handle that quite well. Well, that same concept of getting rid of your fraction is exactly what we're going to be doing in this lesson. We're going to set up, or we're going to work with some equations, and we're going to solve for x or for y or for whatever variable it says. And all we need to do is we need to simplify by getting rid of our fractions. Rational equations contain at least one rational expression, in other words, a fraction. Rational expression is a fraction. We multiply both sides by the least common denominator of the rational expression, and it eliminates the fraction. So that's basically what I just showed you in the previous slide. So again, that's all we're really working on today. A couple things here. This is very important. You must check for extraneous solutions resulting from such multiplication. So because we're going to be getting rid of our fractions, we always got to check our answer to make sure it actually works, because sometimes you may get some answers that are not correct or extraneous. Okay, so here we go. Here's the first example. You guys see here we have to solve this equation. We have our variable, our unknown, is in the denominator. So you're looking at your two denominators, as you guys can see on the screen here, x plus 3 and x. And what we got to do is we got to try to get rid of the fraction. So you got to ask yourself the question, what's the least common multiple or least common denominator between x and x plus 3? Well, like was discussed on 9.4, the way we figure that out is we just multiply the denominator. So we would say x times x plus 3 would be my least common denominator. So notice in the text here, I don't really care for how they do this, but it's quite all right to do this. They take parentheses and put the entire equation. They take this entire equation and put it in parentheses and multiply by the least common denominator. Me personally, I don't do that, and you guys can do it either way you would choose. What I actually do, and it may seem like a little extra work, but I literally write out what the least common denominator is on each side of the equation, because I'm going to multiply every single term by that least common denominator. Again, notice they put the entire equation in parentheses, and you guys can do this and multiply it out, but some students prefer to do it how I have it in blue, because notice how I have it in blue. It's going to be the same concept, it just looks a little bit different. Notice in blue here, some pieces are going to cancel. This is going to cancel with this. This x will cancel with this x. So you're literally left with 18x is equal to 12. times the quantity x plus 3. And you distribute out the 12 and you solve for x. The way they're recommending to do it or showing how to do it is, it's a viable way. There's nothing wrong with it. You just multiply everything out by that. So literally what you do here is you use distributive property. That times the first term, and then whatever's on the right side of the equation, you multiply it out too. The same thing happens. The terms will cancel, and you end up with the same exact resulting equation. It's just a matter of which method you prefer. I'll accept either method. It really doesn't matter. You either find the least common denominator and multiply every single term like I did in blue up top, or you just draw parentheses around the entire equation and then use distributive property. It's really completely up to you. You just keep simplifying this, so they keep working it out, and they get x is equal to 6. But remember, anytime you have a least common denominator and it has a variable in it, you always have to check for extraneous answers. So what we need to do is take 6 and plug it back into the original equation. So they just take that value for x and they plug it in right here for x and also right here for x. And that's what they end up with there. So they simplify it and they get 2 does equal 2, so they know that 6 is the correct answer for this particular equation. Well, guys, that's pretty much it. Now, believe it or not, that's the entire lesson. Now, they're going to give you some that may be a little bit more difficult, and we're going to look at one of those in just a moment. Proportions of our special types of ratio equations. The product of the extremes and means is equal to the product of the means. It's just talking about some ratios here. That's another way that you can do it. On the previous equation, I had one fraction equals another fraction. You could have cross multiplied because you would have a ratio and solve for the unknown. So there's actually a couple of different ways to solve these problems. It really depends on how you guys look at it and how you want to work the problem. So we have another rational equation here. It looks very intimidating, but it's not too bad. Again, remember, the secret to this is find the least common denominator. So what you would have to do for the first step is you need to go ahead and factor, and that's what's done here. They take this denominator and they factor it. So again, you want to find the products of -4. When you add them together, give you a -3. Well, that's -4 and +1. So that's factoring. Y'all should be masters at that by now. So the first step is to factor in the denominators that need to be factored. And then you're looking for the least common denominator. So I'm looking at each term, and I'm looking for the fraction that has the term mentioned the most. So here you have an x minus 4. Here you have an x minus 4. There's no x minus 4 over here, so the most it's represented is just 1 time x minus 4. And then you have an x plus 1 right here and x plus 1 right here. There's no x plus 1 over here, so each fraction, the one that's mentioned the most, is x plus 1. Now just let me remind you guys, if for some reason on this denominator you would have had an x plus 1 times x plus 1, here you guys see that you have it 2 times. You always have to take the one that has the most. So this one has 1, but this one has 2. You have to take the one that has the most. That concept doesn't apply here though, since we only have 1 in each one. So my least common denominator here is literally x minus 4 times x plus 1. The text, what they're going to recommend to do is put there's the least common denominator, as we've already talked about. They're going to say multiply the whole thing by that least common denominator. Okay, you can do that if you want to. That's perfectly fine. The other option is to do what I said to do, and that's literally multiply everything by that least common denominator. So the red here will represent what's being multiplied times the first term. Then I'd multiply this times x minus 4 times x plus 1. And by doing that, guys, you can see what cancels. Here on this side, oops, that's incorrect. On this side, the x minus 4 would cancel. Here it all would cancel. And here the x plus 1 would cancel. So then you just multiply it out, and you're going to get what the text, what the screen actually has here. You have x plus 1 times x plus 2. That's what they have right here. And then over here, nothing happens with the 30 because everything canceled out. But on the end, you'd have the 4 times the x minus 4. So that's kind of what happens with all of this particular problem. So let me clean this up just a little bit here. So we get 30 for that piece, and then 4 times x minus 4. They just simplify this. You have to FOIL this side out over here, so FOIL that out, and you'd end up with what they have there, the x squared plus 3x plus 2, so that's basic algebra there. And here, right, really, guys, you're just solving for x. But you guys hopefully notice you have a quadratic here. So since you have a quadratic, it's probably a good indication that you want to get everything on one side of the equation. So literally, they move the 30 over, they move the 4x over, they move the negative 16 over, and move everything over, and they simplify it, and they get this trinomial, or quadratic. So here again, you want to check and see if you can factor it to actually get your answers for x. And this is what they end up with. When you factor it, you get x plus 3 and x minus 4. Now remember, you're saying this times this equals 0. So that means one of them has to be equal to 0. So you literally say x plus 3 equals 0 and x minus 4 equals 0. And when you do, you get two answers for x. You get x is equal to negative 3 and x is equal to positive 4. So those are the two values that you get for x. But remember what I told you guys, anytime you have these types of problems, you always have to check your work. Always. So I got to check these two values to make sure they work. So if you plug it back into your original equation, this one's actually quite simple, because if I plug in 4 right here, that's going to give me 4 minus 4, which we know is equal to 0. So that literally means this denominator here becomes 0, which it cannot be. That violates a rule of mathematics that states you can't divide by 0. So you got to check it, and when you do, you figure out that 4 is not a possible solution, so that's literally taken out of your answer. That's how it works. Find your least common denominator, multiply it out, and then you simplify, and you always check your answer. So the only answer for this problem is negative 3. Okay, so now let's look at some word problems, okay? This isn't super difficult. You can do this a couple of different ways. You can do this setting up with two equations, but this lesson is wanting to teach you how to set it up with one variable. So I'm still going to end up with two equations, but one variable. So notice this problem says find two positive numbers whose difference is 6. So that's the key. Their difference is 6, meaning we subtract the two numbers and we get 6. And then it says the sum of the reciprocals is 1/4. Okay, so the first step on this one is to make what's called let statements, okay? They're called let statements because it has the word let, okay? So let x be the first number, whatever that is. It could be any number. We're actually going to solve for it to figure out what number it is. So x is the first number. So that would tell us that x plus 6 is equal to the second number. Now the way that's figured out is the two positive numbers such that their difference is 6. The difference of two numbers is 6. So it's x plus the second number equals, x minus the second number is the way you can think about it. The second number is equal to 6. So what they do here is they just solve for the second number. So they move that over to the right side, move the 6 over to the left side. So you get the equation x minus, actually here it'd be x minus 6 is equal to the second number. The difference is 6. So if you want to take the x or the second, it really could be switched around depending on how you want to write it. But they end up getting the equation x plus 6 is equal to the second number. Then the reciprocal of the two numbers, the sum of the reciprocals right here, is equal to 1/4. So 1 over x plus 1 over x plus 6 is equal to 1/4. Well, you guys probably understand why they include this in this lesson, because this is a rational equation. So the way we solve that is we multiply everything by the least common denominator. The least common denominator, again, this text is going to recommend put this whole thing in parentheses. The least common denominator is this times this times this. So literally 4x times x plus 6. And then you use distributive property, and then you're going to get your final answer. That's one method. For some reason, some students prefer the other method. Multiply everything times the common denominator, or least common denominator, I should say, or least common multiple, I should say, actually. So 4x times x plus 6, and then this side times 4x times x plus 6. And then you can see what cancels. Here an x cancels. Here the x plus 6 cancels, and here a 4 cancels. You can do it either way. I'm not trying to confuse you guys. There's two viable ways to do it. You do whichever way works best for you. But then you just solve that equation. There's the least common denominator. Multiply everything out by the least common denominator, and you end up with 4 times the quantity x plus 6. 4x equals x times x plus 6. And then you just simplify this. This one we're actually going to get another quadratic. So we factor it, and we're going to get 6 and negative 4. But remember, if you look at the original problem, notice it says 2 positive numbers. These are not 2 positive numbers, so only one of them is going to be included in my answer, which in this case is 6. So 6 is an answer. It does check out. It works. So the numbers are 6 and 12. The reason I know it's 6 and 12 is because it said the sum of two, or the difference of two numbers, was 6. Well, if basically I have to ask myself what minus 6 is equal to 6, I've got to substitute it back into that equation, and that obviously would be 12. So with these, you're always going to have 2 answers because you're looking for, again, find 2 positive numbers here. So the secret is set up the equations, making your let statements, and then solve, in this case, the rational equation. Okay, that'll take a little bit of practice, but I think you guys can do it. Now, this is actually an important concept. I know some of you guys have different businesses. I know some of you cut grass in the summer. I know some of you do some other things. This is actually a pretty important concept here because if I'm going to run a successful business that has to do with the rate of how fast someone does something, it could be detailing a car, it could be cutting a yard, it could be washing like plates, or it could be anything. I mean, any job that has a certain amount of things that are accomplished over a certain amount of time. Sometimes ladies clean houses. I know a lot of high school students, ladies that have done that before. So maybe they can clean, I don't know, they could clean a 3-bedroom house or a 4-bedroom house in a certain amount of time. We can figure out how long it's going to take you to do things, and therefore you can figure out how much you need to charge. And actually also figure how much money you're going to end up making if you can cut. Now here's the difference though. These types of problems are going to be adding somebody on. So let's say I had a lawn business and I had one riding lawnmower and I had one push mower. Well, obviously the riding lawnmower is going to usually cut a yard faster than the push mower. So I could figure out the rate it would take me to cut it with a riding lawnmower, and then let's say it's 3 acres, and I need to, man, it's going to take me forever to cut that. So I'm going to get the guy that's on the riding lawnmower and the push mower, and they're going to work together to cut the yard. How long is it going to take both of them to cut it? Well, we understand their rates are different. Like the riding lawnmower can cut it in a much faster rate than the push mower. So the question is, what happens when you add things together that don't accomplish things at the same rate? And that's what this concept is. So it's actually very important. Maybe it could be done. I know people that paint houses or paint inside or do something like that. Let's say a person is a very fast painter and they can paint a room in 30 minutes. And then they have another guy that can paint the room in an hour. Well, if they both work together, you can figure out how long it's going to take them to paint the entire house. So it's actually a very valuable process in order to be able to use people efficiently when it comes to different types of businesses like that. So it's actually pretty important. Now the concept though is very basic. If a job can be completed in 6 hours, then we're always going to represent the rate of something, in this case the rate of accomplishment. So the rate is always going to be equal to the number of jobs divided by the time. So that's just the little simple generic equation. The rate of somebody being able to cut a yard, let's say that can complete 1 yard, that would be 1 job in 30 minutes. Well, that would be 1 over 30, or if it was in terms of hours, 1 over 0.5 for half an hour. Let's say, I don't know, it took a young lady 6 hours to clean 2 houses. Well, that would be 2 jobs over 6 hours. So that's kind of the way this works, and it's actually a very important equation to be able to figure some of these pieces out. So the rate of working together is the sum of the rates, individual rates. So what that's saying is sometimes the equation could be written as the rate of the first person times the time plus the rate of the second person times the time is equal to total jobs, is a way you can think about it, like how many they're going to accomplish. So the first rate times the amount of time they worked plus the second rate times the amount of time they worked equals the amount of jobs that they're trying to complete. So that's the basic equation there that can be used in order to figure this information out. Okay, so let's look at a problem. This is actually on page 400, I believe, in your ebook, and it's actually a pretty practical problem. You know, pumps, people that fill up their pools with water are usually, sometimes they're going to be pumping water in. I know with aquarium, if you guys have ever seen that TV show Tanked, where these guys come in and they make these amazing aquariums where they're filling that aquarium up with water, but they have to pump in that water. So maybe they have two different pumps. If it's a big aquarium, they're going to try to calculate how long it's going to take for the pump to fill. Well, they actually could use this concept, this formulas that we're talking about in this problem to figure that out. But anyways, a large pool can be filled in 8 hours of a continuous pumping using pump A. So that's the first pump, pump A, and it can fill up one pool, so that would be the jobs 1 in 8 hours. If a smaller pump B worked with pump A, it only takes 6 hours to fill the pool. Okay, so you have two pumps, pump A, pump B. You know how many jobs and how long it will take pump A to complete it. Again, it's one pool, one large pool in 8 hours, so that's one pool in every 8 hours. But working together, it only takes them 6 hours to complete it. How long would it take to fill the pool with only using pump B? So here we're actually looking for a time in essence, and technically it's going to be their rate. How long will it take them to fill one pool in how long will it take them to fill that one pool, swimming pool, with just pump B? So here it is again, let T equal the time for pump B to fill the pool along. So you can pick any variable you want. You could pick X, you could pick whatever. The reason I picked T here is because of time, how long, so they're going to use time. So the best way to do this is to set up a little chart here. Again, let T be time, and then you just fill it in. All right, so here we go. We're going to fill it in our information. We're saying that the time for pump B to complete it is T. Well, again, if you're looking on page 400, or you remember from the previous slide, it said that pump A could complete it in 8 hours. So we're working together, it says that they could fill the pool in 6 hours. Okay, well, that means that the rate, we always have to set this equation up, the rate of the work. The rate, again, remember, don't forget this, I told you this on the previous slide, it's always number of jobs divided by time. Okay, so it said they could complete one pool in 8 hours. Well, what do you think the other pieces are going to be? Well, 1 over T for pump B. I don't know what time is, but I know it's a variable. It's variable T. And then working together, they can complete one pool, or fill one pool up in 6 hours. Well, there we go. Remember what we said on the previous slides? We said if you take this rate and add it to this rate, it will equal this rate. So add going down, so plus, and then equals this. That's how you set up this equation. And once again, you guys probably understand why this is on this lesson, because this is a rational equation. We have denominators, and our unknown is in the denominator. So the way we solve this is get rid of your fractions. The way we get rid of our fractions is find the least common denominator, multiply everything by the least common denominator, and then simply solve your equation. So this is what we're going to do on this slide here. Or maybe we're not. Sorry about that. Yeah, so you would have to set that up. I don't have it. If I plugged all this stuff in here. Sorry, I didn't have it. I don't have the final answer. It looks like the final answer, if you look at the problem on page 400, it's going to be equal to 24. So the time that it would take the pump B to fill it up is 24 hours. Again, we would set that up in this equation. I guess I can try to squeeze it on the screen here. Y'all have it in the textbook. I'm going to multiply everything by 48t. That's just the way I do it. Here, 8 goes into 48 6 times. So that's 6t times 1, which is 6t. And then here the t's cancel. So I get 48 times 1, which is 48. And then over on this side, 6 goes into 48 8 times, and that gives me 8t. So then it's just basic algebra. Subtract 6t from both sides. So I'm going to get 48 is equal to 2t. So what times 2 is 48? That obviously would be 24. Your time is in hours here. because it said you could complete one pull in 8 hours. This was 8 hours. This was T hours. This was 6 hours. So now my unit is hours. So it would take this pump B significantly longer to fill that entire pool. In fact, it takes an entire day. So actually pretty practical because you could figure all this information out using these basic equations. You can use this with other equations as well. Some problems, some distance problems can be used by solving this. Rate equals distance over time. We know that the equation distance is equal to rate times time. So you could solve that for time or solve it for rate depending on what it's asking for. So here's an example of a concept here. Andrew drives the first third of the distance of Roanoke Rapids to Wilmington at an average speed of 52 miles per hour. What average speed must he maintain for the rest of the trip if he wants an average 60 miles per hour over the course of his entire trip? So pretty practical for us here in North Carolina, Roanoke Rapids to Wilmington, how long it's going to take. So the way we set this up is D is equal to distance. That's the entire distance. R is the average speed of the second part of the trip. And then we can set this up in an equation. So you have the first part, the second part, and then the total trip. So make that chart just like we did here. Rate times time equals distance. We've already dealt with a lot of these problems. Rate times time equals distance. We've already done this. So the first rate it said according to the problem on example 5, which again, if you're looking at it, I believe this is also on page 400. So just filling it in. The total distance is D. I don't know what it is. I just know that it's a total distance. I know the second rate is R. I know the first rate is 52. I know the total is 60. The time allotted is, again, all this is from the information, 1/3 D. And then 1/3 D plus 2/3 equals 2/3. Remember on these charts, we multiply going across and we add going down. So you would say, if I know my total is D, and I know my first part is 1/3, I say what plus 1/3 is going to be equal to 1D, and that's to 2/3. So you add going down, you multiply going across. So here, if you're wanting to find the time, you divide. Remember, rate times time equals distance. Rate times time equals distance. Or if you prefer, the equation could be written backwards. Distance equals rate times time. It's the same concept. So if that's the case and we're looking for time, I could divide both sides by the rate. And distance divided by rate is equal to time. So if the distance is D and the rate is 60, then I know that the time is D over 60. I could figure out this information the same way with the other times. Again, it looks confusing. It's just simply taking the distance and dividing it by the time. And then the last one, you just fill in your box. And you multiply across and you add going down. So you set this up in a rational equation. Once again, using all of these pieces that the D, in this case, you're taking the time and then you're adding it. You add going down, remember what I stated? Add going down. So the D and 3 times 52 is what they have right here. And then they have plus this piece right here is going to equal the distance over 60. So you divide each term by D. And by doing that, you're going to cancel out the D variables, get rid of the D. And then you're left with this fractional equation here that you just solve for R, just like we did on the previous problems. Find the least common denominator, get rid of your fractions, and then you're going to get your final answer. Okay? All right, so that is the lesson. You guys, again, can watch this at any time on the YouTube channel that I've created. The teacher could give you access to that, or you guys could just pull it up online and look at it yourself. What I want y'all to do for homework, I want y'all to get some good practice in. Again, I'm just going to be similar to the previous lesson. I know it's Wednesday, so you guys have church tonight, but this assignment will be due on Friday. So you have actually 2 nights to get it completed, assuming most of you will be in church, hopefully all of you in church tonight, Wednesday night. But again, I want you to do what you guys did on the last lesson in order to get some good practice in on this. So I want you to do numbers 3 through, this time we're going to do 3 through, let's do 3 through 33. 3 through 33. And this time I want you guys to do the odd problems. So 3 through 33 odd. And that'll give you some good practice for these types of problems. But again, this lesson will be due on Friday. Hope y'all have an awesome day and a wonderful rest of the week. Looking forward to seeing you guys later next week when I get back. But I know it's a very busy time of the year. You guys probably working on junior, senior, trying to finalize some things even this week. But I'm praying for you, thinking about you. I hope you have an awesome day.